Alrighty. I think that I am live. I just want to check first of all whether I'm audible. Hello everyone. Am I audible? Can people hear me? We'll just test that out. This is a new streaming setup for me, so it's possible that it's not working. We'll have to mess around with it a little bit. I'm also just going to try tuning the desktop audio a bit. Okay, so I think we are live. I'm now just also trying to patch in Jenny, who is the author of this assignment, and hopefully once we've got her in the call, we should be able to get started. Alrighty, Jenny, can you hear me now? Okay, I can. Let me just see if the rest of the world can hear you as well. Okay, I'm audible, great. Is Jenny audible as well? Looks like possibly not. Alright. Yeah, there's definitely a delay between me and the video. Okay, in which case we may need to go with the secondary option, which is not having you live on the call, which is slightly awkward. I'm sorry about that, but in that case you'll be able to talk to me and you can let me know if there's something there. So everyone knows, Jenny King is on the call with us. Jenny is one of our wonderful tutors and helped author Minesweeper, the assignment that we're working on. So there's one more thing I can try to see if I can get you on the call, but if not, let's see. If
I can also just type in chat if wanted.
That's also true. That may be a good way of doing things. Just see if that's made anything better. Otherwise, what I will do is I'll get started. We'll work on that for assignment 2 when we do one of these for assignment 2 as well. Alrighty. Let's get started then. I prepared some brief slides. The slides aren't really important so much as just directing what we're going to talk about today, but I do want to be clear that if anybody has questions or comments, you are absolutely more than welcome to post it in the chat. Jenny will be in the chat. I can see we've got a few other tutors in the chat as well, and I'm sure they'll be able to answer any questions you've got or refer them to me. Let me now go to my slides. Excellent. Here we go. So, this term for COMP1511, assignment 1 is going to be Minesweeper. What I'm planning on doing today is going through all of these things. So first of all, I'm going to talk about what assignment 1 is actually about. Like, why do we have an assignment 1? Then I'm going to talk through the specifics of what we're going to be covering in assignment 1. Then Minesweeper in general. And then sort of walk through the spec in general terms, and then talk through how to get set up. We'll talk through stage by stage, including a discussion about the extension work. I'll give some tips, and I'm sure there'll be other people in the chat as well who are more than willing to give tips. It was things echoing. Possibly. Let's do that. Is the echo fixed? Okay, it looks like the echo is fixed now. Apologies. All right, that should be fixed now. I think that's because it was coming in from the audio. All right, brilliant. we'll stick with this for this time. I'm going to make sure that this is all fixed for the next time that we go live. I thought I'd gotten it working better, but apparently not. So that's sort of the outline for today, but as I said, if there are any questions, I'm sure that we'll be able to answer them. Let's get started first of all on like what is assignment 1. So as you hopefully know, there are 2 assignments that we'll cover in COMP1511. This one is assessing effectively everything we've learned from week 1 to week 4. So there's a list in the assignment of exactly what that is. I've copied that in here. Int variables, if statements, including relational and logical operators, that's things like and greater than, those kind of things. While loops, int arrays, including 2-dimensional arrays, which is something that we've just covered today, and which we'll look into in a bit more detail over the coming week or 2. Printf and scanf, as well as functions. So that's pretty much all the knowledge that you will need for assignment 1. There's nothing special that you'll learn about in a few weeks' time that will make assignment 1 incredibly much easier. So if you're feeling comfortable with these things, then you've got everything you need to be able to get through assignment 1. I did want to particularly talk about 2D arrays though, because they are sort of the foundation of this assignment, and as a result, I figured it might be a good idea just to briefly talk about them, just so that everybody's sort of on the same page. So this is copied from the starter code of Minesweeper. Minesweeper has starter code. It's a piece of code that we've written. Most of it is blank, but it just gives you some functions already completed. So things like printing out the Minesweeper grid, or the minefield as this is called. We give you a function to do that to make it easier for you to start. Basically, there are 2 important parts of this piece of code. We define size to be 8. That means that the minefield is an 8 by 8 minefield, and then we give you this array. This is the minefield, which is a 8 by 8 array. And the idea of this assignment is that we're going to be playing a game called Minesweeper, which is basically entirely stored inside this array. By the end of the assignment, you'll be printing out the array in a format that looks like this, and you'll be scanning in commands that give you a bunch of different ways to modify this array. But what I wanted to do before we sort of go into this assignment is talk about, well, what is Minesweeper then? If you are looking to convince your friends and family that you are doing work whilst actually playing a game, have a Google for play Minesweeper, and you can call this research. If we click play, here is a game of Minesweeper, hopefully, if it's going to work. There we go. When you start Minesweeper, the entire board is invisible. And what you are doing is effectively you are looking for mines. Let's click somewhere. You click somewhere, and as we can see, we've cleared out a bunch of the board. Everywhere that's sort of an empty, sort of pinkish colored square, that square is safe. But then some of the squares have numbers next to them. Those numbers say basically the square next to me has a mine. I believe it's actually anywhere in the radius sort of a 9 squares around me. It counts the number of mines in that area. Something to that effect. And the point of the game is to start clicking on squares that are unrevealed. If you click on a square that is a mine, as we've just seen, the game ends and everything blows up. If, however, I'm going to change this to easy so that hopefully there are less mines. If I do this, what I'm seeing now is, well, we've cleared out a bunch of the space. If I now select another mine, now we can see if you click on a square that is not revealed and it's not a mine, you'll see how many mines around it exist. So the way that you play this game is you're supposed to keep revealing those squares that aren't that are not revealed. One of the things that this game lets you do is flag mines. So if you believe that there is a mine, you can flag it, and the game ends if you've either successfully flagged all the mines that are mines, or you lose if you click on a spot and there is a mine there. That's the summary of how this game works. Now, obviously, this will be useful for research, but we give you all of the details that you need to complete this assignment without having to play a single game of Minesweeper. This is just so you've got the context of how Minesweeper works. Also worth noting, some of the things which the real game of Minesweeper does, require techniques that we may not have shown you yet. So we've changed the rules of the game slightly, so it still should be playable, but it's just slightly different from what you might find on Windows. So that's a general introduction to Minesweeper, the game. Now what I want to do is just sort of talk through the specification for this assignment. If you go to the course website, you will now see in the top banner, and also here, assignment 1. You can click on that and you can find the assignment. The assignment comes with some introductory text. It also links to the Google search game that I was playing earlier. And effectively what it explains is what is Minesweeper and what are we doing. There is a lot of introductory context to this assignment. I'll walk through it in more detail in a moment, but I'm just going to breeze over it first of all, just so we can sort of look at the whole assessment document. It first of all describes what your task is. So your task is to implement this game. It gives you some information around what the minefield looks like. So this is what we saw earlier as those like unrevealed squares. It gives you some information on hash defines which you've been provided. Those hash defines are important because they tell you the state of any particular square in the minefield. So it could be visible safe, which means that we've revealed it and it wasn't a mine. It could be hidden safe, which means that it's hidden, but we secretly know that it is safe. Or it could be hidden mine, which means we secretly know that it is actually a mine. So we can read through this. There's some information on how revealing works. Revealing works slightly differently to what you would expect the game we played works. We can have a read through, and it explains basically you can either win the game by revealing everything except those containing mines, or you can lose the game by attempting to reveal a square containing a mine. Now, there's a question in the chat. Can you show us how the Minesweeper program should work? Presumably that's the Minesweeper program that we should make. And that is an excellent question, because what we'll find is that there is actually a sample solution that we've given you. The sample solution is provided by running the command 1511 Minesweeper. And in a moment, I'll open up VLab and I'll run that command for you. First of all, I just want to quickly scroll through the rest of the assignment document so we just sort of get familiar. Our task is described to us, so we're given a list of allowed C features. We're given some starter code. That starter code is really important. That will, zoom in on the spec. Okay. That starter code lets you gives you a place to start with. In theory, you could implement the assignment entirely from the specification, but we recommend that you start with the starter code. It gives you a description of how we control our program. So for those of you who've seen the lecture this week, you will have seen that we've tried some scanning in. We've been using scanf to scan in integers which controlled a traveler on a map. This assignment works in a very similar way in that we scan in integers and that controls what happens on the board. So we can see here that we will scan in at the start where all the mines are, and then later on we're going to scan in commands, and those commands will either do things like check that a particular row or a particular square is safe, or it will reveal a particular square. So the next thing to note is that the actual body of this assignment, once you've read through all that sort of introductory material, is split into 5 stages. Again, we'll walk through the stages in more detail in a moment, but each stage comes with a rationale, which explains why we're assessing you on this, what marks you'll get, and what help you can get with it. It will explain how you can test that stage, and then it'll give you a general description of what we're asking you to do. In the first few stages, the description is quite specific. It tells you exactly what we want. In the last few stages, the description is more general, and we're expecting you to some extent to look at the sample solution to decide exactly how it should work. So you can also see, for instance, invalid inputs. We described to you what inputs you could get and what inputs you won't get, and we'll give you some examples. The same structure is followed for stage 2, stage 3, stage 4, and stage 5. We even give you some extra challenges if you're really interested in them. We then describe the style rules, so you can find out how to run 1511 style, and we'll also tell you that you should fix your, you should get humans to look at your style, or at least you should consider what a human looking at your style would think. We explained to you how you can test your code. There are a few different mechanisms. You can compile your code yourself. You can run auto test. Auto test is provided just like in a lab exercise, and there's also a reference implementation. There's also finally some sort of matter at the end about the rules for this assignment. Specifically, it's important to note that work that you submit for this assignment has to be your own work. If you submit anything that is not your work, you will need to attribute it. So for instance, if you're copying a small amount of code off Stack Overflow or something like that, you would absolutely need to attribute it. If you're copying from lecture or tutorial code, as Andrew said, you should have a comment saying where it came from. But certainly the work you should be doing should be just your work. You shouldn't be getting anyone else to do your assignment for you. There's information on submission of work, which is here. There's also information on the assessment scheme. I'll talk about the assessment scheme now, just because we might get a few questions about it later. The assignment is split into two parts, the core part and the extension part. For the core part, you will get 65% of the final mark for assignment 1 is for performance. So basically, how well do you pass the auto tests that we've given you? I'll note that just like labs, we have marking tests, which are very slightly different to the auto tests. But for the core component, we're not really trying to catch you out. We will give you some general indications of have you gotten the requisite properties that we wanted from you from stage 1, stage 2, stage 3. We'll give you auto tests for those, and then later on we will use the auto marking just to confirm that you've done what we asked you to do. So that's 65% of the assignment 1 mark. 15% of the assignment 1 mark is for style, so that's basically how human readable was your code. A lot of that you can get by just running 1511 style, but also it's possible to get. You'll need to have a read over it and think about what would a human think, because your tutors will be marking your style. Separately then, so that by itself is 80% of the course mark, 80% of the assignment 1 mark. The other 20% is split between flag mines, which is stage 4, and diffuse, which is stage 5. And so basically for those, you will need to, we'll talk about them later, but there's 10% for submitting everything that you need for each of those. Overall, that sums up to 100%, and that 100% will then become 15% of your course mark. So assignment 1 in its entirety is worth 15% of your course mark. There's some more information about marking here. The one thing that I think it's really important to note at this point is that this is somewhat different to assignments that you might have done in, say, high school or in other places. We don't expect that every student in this course will get 100% in assignment 1. And not only is that okay, it's absolutely expected. So what we've tried to do is we've broken it down into, if you are trying to get the absolute most out of this course, if you are really going all in on COMP1511, it's possible to get 100%, and you're going to learn a lot. You will only need the skills that we've taught you in the first 4 weeks of this course, but it will require a reasonable amount of time and effort. It's also possible for you to say, I'm enjoying COMP1511, but I've also got other subjects. I want to learn what I can, but also not spend large amounts of time, in which case most of the core assignment will be doable, but the extension sections might take more time than it would make sense for you to put in. And that's okay. So different people may choose to put in different levels of effort or get to different stages. It's not like you need to get 100% in this assignment. That's just not how we think about assignments in COMP1511. Okay, that's a general walkthrough of the assignment. What I might do now is I'll open up VLab just so we can play around with the assignment a little bit, and also so that I'll show you how we can actually get started. One moment while I switch over into VLab. We will try and do this. Okay. Where is it? VLab. Oh, there we go. Good, it's found VLab. I'm just going to run a command to fix up my screen. There we go. Cool. So hopefully now my screen is visible to everyone. I'll just check that that is in fact working. Yeah, excellent. So first thing that we would want to look at is what is actually in this assignment. What am I supposed to be producing? The answer, have a look at what the reference solution does. So 1511 Minesweeper. It says, welcome to Minesweeper. How many mines? So at this point, it's asking me how many mines would I like to put on the minefield. Let's say I want to put 5 mines in. I'll type in 5. And then now it says enter pairs. At this point, what it's asking me to do is tell me exactly where on the minefield do I want to be putting my mines. So I might say I want to put them at row 1, column 1. I might want to put it at row 2, column 3, row 2, column 4, row 3, column 3, and row 3, column 4. Okay, and now it says game started, and what we can see here is that this is a printout of what the array that is the minefield looks like in memory. So what we can see here is we have a bunch of 1s on the first row. On the second row, we've got a mine in the second column, effectively at coordinates 1, 1. We've got another mine at coordinates 2, 3, 2, 4, 3, 3, and 3, 4. So to be clear, this is the first thing that we would have needed to have done in our assignment. We needed to support entering these pairs. Once we've done that, now it just gives us an empty spot, and it's asking us for input. And so what we would do, we can go back to the specification. Let me jump across to the specification, and here we go. We can go up to Minesweeper stage 1. We've already seen placing mines. And now it also tells us the other thing we can do, which is counting the number of mines in a row. So I can run the command 1 meaning count number of mines in a row. I give it some coordinates in row 1, and then I say from column 0 to 4. So let's try that out. Count the number of mines in row 1 from 0 to column 4. And we get told there's 1 mine in row 1 from column 0 to column 4. At this point, you've now got all the tools that you need to be able to go and explore the assignment yourself. I'm not going to walk through every single command that we could type in here, but if you want to go and understand how should this command work or how should this particular part work, this is where you would go. You run 1511 Minesweeper, and then you're able to enter in whatever you would like. This is one of the really good ways to just get started on understanding how this assignment works. Have a play around with it, try and understand what's going on, test out how stage 1 works. You'll be able to see how this assignment works. So I'll jump back to VLab, and we can see here, I typed in 1, 1, 0, 5, and it says there's 1 mine from row 1 to column 0, from column 0 to 4. So 1511 Minesweeper is a great way of understanding exactly how this assignment is supposed to work. What I might do now, the next thing I'm going to do, is let's say that we're sort of reasonably understanding, okay, I understand the outcome. I want to end up with a program called Minesweeper that does some of these things that are specified in the specification. So how can I get started? What do I need to do? Well, step 1 is we're going to make a new directory. I'm going to call it assignment 1. You can call it whatever makes the most sense for you. And now I'm going to change directory into that. And if we have a look at the specification, which I'll show here, if we go up to the top, it gives us this instruction about starter code. And it says download the starter code here, or use this command on your CSE account. Now, if you're on your own computer and you plan on doing development entirely on your own computer, you can use this link here to download it. We recommend using what we've shown you in class so far, which would be using VLab. So for VLab, I'm going to copy this instruction. I'm going to jump back over into VLab. And now I can paste this. So this instruction basically just says copy from this place. This is inside our class account, so this is like where we keep all of our classes files, to dot meaning the current directory. And this n back here, don't really need to worry about it. All it means is just please don't overwrite things. So if you run this command once you've already created Minesweeper, it's not going to overwrite that, because obviously that might cause a few problems. Okay, so the next thing we might do is let's take a look at the file that we've gotten, minesweeper.c. I'm going to open it and get it, and I'm going to make this full screen. So the first thing we can see at the top is the assignment header. If you would like some free marks, I would recommend filling in your name, the date, and the ZID, because one of the things that we're looking for when we're marking you on style is have you filled in a header that explains who you are. The next thing we go down is the include stdio.h. We've already seen this one. We include stdlib.h. If you haven't seen it, you don't need to worry about it. It's just because some people may find some of the functions in there useful for part of the assignment. There are 3 possible states, and you'll see that we mentioned this very briefly earlier when we were talking about the specification. The 3 possible states are either a visible safe square, which would mean we've clicked on it or we've selected it and there was no mine there. A hidden safe, which means we haven't checked it yet, but it's safe. Or a hidden mine, which means we haven't checked it yet, but secretly it's a mine. We've already seen this hash define for size. This is the size of the grid. And then there are hash defines for each of the possible commands that we could ask you to implement. They're actually in order from stage 1 to stage 5, which is slightly useful because it means that you sort of know you shouldn't need to be worrying about flag, mine, or diffuse until you're pretty comfortably done with reveal cross or detect square. There's also space for you to add your own extra hash defines. This is a hint. Again, one of the things that is really, really useful during this assignment is being able to add your own hash defines. If you see something where you're saying, this is a number that I haven't quite explained or that is just appearing out of nowhere, you can use this space to add hash defines for them, and we strongly recommend that you do that. Okay. Next, there are 2 functions. These are the functions that I mentioned earlier we'd given you because they make your life easier. One of them is called Initialize Field, and the other one is called Print Debug Minefield. Recall that they're at the top of the file because even though they're implemented at the bottom, we need to give the hint to the main function, basically to say, by the way, I haven't told you what they are yet, but these are the 2 functions that you've got access to. I'll scroll past the main function for the moment just to show you what each of these are. This one just initializes every field in the minefield, every square in the minefield to be hidden safe. What does that mean? It just means we're initializing every field in the minefield, every square in the minefield to not contain a mine, but to be hidden. And this is a starting point from which we can then fill up the board with mines if we want to do that. There's another function. This one is called Print Debug Minefield. And what this does is it means that we're able to print out each of the elements of the minefield exactly, or each of the squares of the minefield, just like we saw here. So this was printed out probably using Print Debug Minefield. It is unlikely that you will need to change these functions. Possible, but unlikely. That's yes. So if you feel like you need to change them, just have a think about whether there's another way that you might be able to achieve the same thing. Finally, let's take a look at the main function. This main function is nice because it gives you all of those particular things that we wanted you to print out already there. So you don't need to worry about maybe I've mistyped the word pairs. That's okay because you've already got all of the text here. And let's have a step through it. Well, it says initialize minefield. So this is creating a minefield of size by size. So it'll be an 8x8 minefield. Initialize field, whose job is set everything in this minefield to 0. To the constant hidden safe. So in fact, I believe it will initialize everything in the minefield to 1, not 0. Excuse me. It then prints out welcome to Minesweeper. It asks you how many mines, and then you can see this first to-do here. This to-do is hinting to you something needs to be done by you. In this case, you're going to need to write the code that scans in the number of pairs of mines. Then here, we're going to need to actually write the code that scans in those pairs of mines and puts them in the right place in the grid. Finally, part number 3, effectively we need to scan in commands to play until the game ends. So I would suggest that you're probably going to want to do this one and this one first. That's the first section of the first stage. And then for the rest of the assignment, mostly what you're going to be editing is things here. We've also given you a hint here which says that you should display the minefield after each command has been processed. I would give the hint that there is already a function which will be able to do that for stage 1, which you'll be able to find in this file. So this is the starter code that we've given you. I would recommend have a read through it first. If there's anything in this file that you're not sure about, ask your tutor or ask on the forums. You're totally welcome to ask about just the content that's already here on the forums if you'd like to, just because this stuff is given to everybody. You don't need to worry about spoiling the content of something we've given to the entire course. So what you'll be doing now is you'll be going through, you'll be removing this to-do, be removing this to-do, and replacing them both with code, and then again you'll be replacing this to-do with code. So that's the way that we get started. Once you've actually written some code in here, there are a few ways that we can test this. The first way is that we can run DCC. So obviously I can say DCC-o Minesweeper, minesweeper.c. And then I can run /Minesweeper. Now, unlike the sample solution, this didn't actually ask me about anything. All it did was it said, welcome to Minesweeper, how many mines, enter pairs, and then it told me that the game had started. It printed out a single minefield, and then it stopped. So this code isn't actually functional yet, but it's a starting point from which you can start writing your code. Separately, I could also choose to run 1511 auto test Minesweeper. Yep. Now already it's telling me my code doesn't pass 1511 style. It's also going to tell me that I don't pass any of the tests. Now, this isn't much of a surprise. If we gave you code that already passed the tests, that would probably be a little bit of a problem. Worth noting, by the way, we did get a warning about 1511 style, so maybe we should, I'll just show you that warning here. Let me find it. Yep, so we got a warning here saying my code doesn't pass 1511 style. We could also choose to run 1511 style at this point. And it's going to tell me, I don't have a ZID in my header. That was a hint I gave earlier, so maybe we'd want to add that. But I can run 1511 auto test. I can also run another command which we give you in the specification. I'll just show you that command quickly. And that command is auto test stage. So auto test stage basically lets you only see the auto tests for a particular stage of the assignment. So for instance, if you only want to look at the auto tests for stage 1 or for stage 2, you can use this command. It's quite useful because there are, I think, about 40 auto tests overall, but there's only sort of 6 to 10 for each of the stages. So it's kind of useful to only see the auto tests for the stage that you're working on. Once you've run all of those auto tests, it's probably a good idea to run just 1511 auto test for the entire assignment, just to check you haven't broken anything. But generally, you'll be using auto test stage to test particular parts of the assignment. There's a good question in chat, actually. Does the sample code without any edits pass 1511 style? Almost. The only thing that it doesn't pass is, as you can see here, it doesn't have a ZID in the header. That's because I don't know what your ZID is. So if you filled that in, then the code should pass 1511 style. Alrighty. So what's next on the list of things to talk about? We've spoken a little bit about getting started. I might also just mention quickly, how do you submit this assignment? So it's not enough to just auto test this assignment. You also need to give it when you're done. You can use the give command, give cs1511 as1 minesweeper, minesweeper.c. And just like with your lab exercises, you would say yes and yes. This will also auto test your submission. Obviously, in my case, I'm not going to pass any of those auto tests because I'm just submitting the starter code. But nevertheless, when you're submitting, you can just double check. Ooh. Cool. And so here we can see that we're not passing any auto tests. I'm just going to stop that. It says submission test failed. That's because I haven't passed anything, but I can continue with the submission. And when you see this, your submission is accepted line, that's when you know that you have submitted the assignment. So make sure that you see that, and make sure that you see that before the assignment deadline. Okay, that's an introduction to sort of how you work on the assignment, how you submit the assignment. It might be useful quickly to just do another read through each of the stages of the assignment. And so I'll just do this briefly so that we can get familiar with each of the things that we're asking you to do. Okay. There's a good question there, actually. I'll pause a moment. If people have questions, maybe post them in the chat and I can answer them. How much extra time would the extension parts take comparative to the rest of the assignment? It's very difficult to give an accurate answer on exactly how much longer extension parts will take rather than regular parts. It depends on how comfortable you are. It depends on if you've programmed in C before, perhaps, or those sorts of things. You might find some of it's easier or harder. But I would compare it to saying it's the same difference as going from one of the earlier lab questions to going to a challenge exercise, as it is going from sort of stage 1, stage 2 to stage 4, stage 5. Now, the assignment is larger than any particular lab exercise, but the sort of change in difficulty, I would say, is around that. It's also quite difficult to give average times for stage 1 to stage 3 because there are some students who will complete it in a matter of hours. There are some students who will do it in a week or two. And it depends very much on your experience. Also, sometimes you run into a bug and you'll need somebody's help to fix that bug, and that can take a lot of time. So it's somewhat difficult to estimate exactly how long this assignment will take. Are there any other questions that I can answer? I'll keep an eye on the chat. Nope. What I'll do now is I'll walk through each of the stages. I'll then walk through the extension work, and last I have some tips, and then we can just sort of go into more questions, or if there's anything else that tutors or other people feel that I've missed, we can go into those as well. So let's take a look first of all at stage 1. In stage 1, there are two things that you need to do. As we've already seen, you'll need to be able to place mines. So we can have a look at what that looks like. You need to be able to say how many mines you're placing, and then you enter in the pairs being like a particular location on the minefield, and then you will modify the minefield so that those locations contain mines. That's the first part of stage 1. Once you've done that, the second part of stage 1 is the detect row command. What this does is it's a command that detects whether there are mines in a specific part of a specific row. So we saw that again earlier, but just to be clear, you use the command 1, that means detect inside of a row. You give it a row to detect inside of, and then you tell it a starting column and how many squares you would like to detect from that starting column. So for instance, if I said 1105, what that's saying is go to row 1 on my minefield, that's this row here, and then starting at column 0, go 5 squares over, 1, 2, 3, 4, 5, and tell me how many mines are in this area. So in this case, there's one mine there and there's one mine there. Just to walk through that again, just because there was a question. What does the second one mean? So this first one just means detect inside of a row. So that's the command, as opposed to, for instance, detecting inside of a square. The second one is the index of the row. So this is row 0, this is row 1. The 0 here means a column. So this is column 0. And the 5 is the number of squares that I need to count. So 1, 2, 3, 4, and 5. So I'm counting across these 5 squares. In other words, this is the command, this is the row, this is the starting column, and this is the number of columns to the right of the starting column. Okay. You can also see here that we're expecting you to do a little bit of error checking as well. So in this case, we're asking you to find, to detect inside of a row, detect inside of row with index 3, so that's 0, 1, 2, 3. We're expecting you to start at the 5th column, so 0, 1, 2, 3, 4, and 5. And we're expecting you to count 4 squares from column 5. Now, the mathematically astute among you may have noticed that 1, 2, 3, there's not actually 4 squares that we can count. And so instead of you giving us some number, what we want you to tell us is that the coordinates are not on the map. That's what we're asking you to do for the second part of stage 1. Either detect the number of mines in a particular part of a row, or if we ask you to detect as part of a row that not all of it is on the map, or not all of it is on the minefield, then to tell us so. That's a summary of the second part of stage 1. If there are questions about stage 1, now would be a great time to put them in chat. I'm happy to clarify about that further. The other thing I'll note as well is that your tutors will be more than happy to explain this to you. I'll talk about help sessions at the end, but they're another great place where you can find help. Okay, doesn't look like we've got too many questions for stage 1, so I'll move on to stage 2. There are, I believe, 2 parts to stage 2. The first one is counting the number of mines in a square. Now, this works quite similarly to what we've just seen with counting the number of mines in a row. However, instead of counting inside of one row, we're now counting inside of a square. And so, let's say that this is the minefield. The command that we'll give you is 2, and then we will give you a row and a column, so that's 3 and 3, and then a size, and that's 3 in this case. And what this is saying is detect the number of mines in the 3 by 3 section of the grid that is centered at 3, 3. It's a bit weird, so let's look at a worked example. So I'm detecting inside of a square, that's what this 2 means. I need to find row 3 and column 3, so 0, 1, 2, and 3, 0, 1, 2, and 3. So this is 3, 3 here. And I need to detect the mines that are within the 3 by 3 square centered on this. So what's that 3 by 3 square? It's these 3 squares, these 3 squares, and these 3 squares. I think, in fact, if I try, I can do that. Excellent. So this is the 3 by 3 square which we're going to be detecting mines inside of. And by counting, we can see that there's 1 mine here and 1 mine here. So we would say there are 2 mines in the square centered at row 3, column 3 of size 3. Okay, here's a diagram of exactly what we're asking you to do. The same idea. We've got the rows here, the columns here. Row 3, column 3 is this square, and we're detecting in the 3 by 3 square around it. Now there's a great question in chat. What if it's an even number? Excellent. We tell you down here that you can assume that the size is always an odd positive integer, and you won't have to account for other sizes. So what that means is we guarantee you're never going to get told about, for instance, negative 50, or even the positive number 50, because that's not odd. We also tell you, by the way, that you should check for whether the center coordinate is inside the minefield, and if it isn't, your program should print out coordinates not on map. That's also a useful thing to know. You'll need to test that. Similarly, you'll need to check what happens if it's partly outside the minefield. So there's some information here about how that works. Any questions about the first half of the second stage, just quickly? Okay. For the second half of stage 2, what we're asking you to do is this reveal cross. Now this is how you can do what the equivalent of clicking on a square in the real game of Minesweeper would do. So it's revealing a square. Now this has some particular rules that it follows, so I'm going to step through them one by one. If a selected square contains a mine, then the game is lost and the program should print out game over and end the game. Basically, if I'm saying, please reveal, in this case it would be 5, 6, which is a mine. If I try and reveal this square, the game is over. That's it. If I am not revealing a mine, so let's say I select, please reveal row 1, column 3, then each of the 4 mines connected to the selected square should only be revealed if it isn't a hidden mine and there are no hidden mines adjacent to it. That's a bit weird, so let's talk through it slowly. Each of the adjacent mines So adjacent means anything directly above, directly below, directly to the left, or directly to the right. Each of those mines, you need to then decide, do I reveal them? You reveal them only if they're not a mine and if they're not adjacent to a mine. So here, there are no mines anywhere nearby, which means that each of these adjacent squares we would reveal. So these 4 gray ones get revealed. As a side note, what does it mean to reveal a mine? Well, it means you're going to need to change the value inside of the minefield from whatever the hash defined for hidden safe is to the hash defined for revealed. Okay, let's look at another example though. That was pretty easy. There weren't any mines nearby, so we just revealed sort of the cross pattern around that mine. Down here though, we can see that there is a mine in row 5, column 6. And so for this one, we've got to be a little bit more careful. We know that row 4, column 6 is not a mine, so we reveal it. But then we look at each of the, where is it? We look at each of the four mines connected to this square. So that would be 3, 6, 4, 5, 4, 7, and 5, 6. And we say, is this a mine? Now clearly we can see that 5, 6, row 5, column 6, this is a mine, so we're not going to reveal it. But we can also see that row 4, column 6 has a mine adjacent to it. We can see that diagonally down and to the right, it's got this mine. And similarly, row 4, column 7, that also has a mine adjacent to it. So we've got to be careful here that we don't reveal the mine, we also don't reveal to the left or to the right. But above, at row 3, column 6, this is not adjacent to any mines. You can have a look in the squares directly around it. There's no mines in those 8 squares, so we would reveal this square. At the end, if you have revealed every square except the squares containing mines, then you would print game 1. That's the last thing. Okay, so there are quite a few small steps there, and I'd recommend working through them yourself. Have a think about what happens in this case. Why do all of these squares get revealed? Why does row 3, column 6 get revealed, but not row 5, column 6? Play around with it and make sure that you understand those rules. If you've got any questions, again, this is the sort of thing where you could probably ask that on the forum, or you could certainly ask it to a tutor. We again give you some information about exactly how input should work, and particularly how invalid input should work, and there's even a hint here. I'll talk through the hint at the end, but basically a function would be a really useful thing to use here. And there's some more examples down the bottom as well. Are there any questions about that part of stage 2? I'll give people a moment to post just in case. Okay. Alrighty. We'll get moving on to stage 3, but please feel free to continue asking questions in chat if you've got any. For stage 3, I'll walk through it a little bit faster. There are a few things you'll need to do. You'll need to restrict hints. And all this is doing is it means that you no longer are allowed to use detect row and detect square as many times as you like. You're limited in how many times you can use them. So you're going to need to rewrite your code somehow to be able to only allow somebody to detect to detect row or detect square a certain amount of times. And as you can see, if you try and do it too many times, you'll need to print out the message help already used. So this obviously makes it a little bit more game-like because it's a bit more strategic. The other thing that you'll need to do is particularly important for if you're going to play this as a game, formatted printing. At the moment, we can tell where all the mines are because they're all pretty clearly these 2s here, those are the mines. And that's not particularly productive if you want to make this a game with some suspense or mystery. So formatted printing allows you to print out, I'll show you what it looks like. Instead of printing out something like this, you're going to print out something like this. And so now you can't tell whether all of these squares are hidden safe or hidden mine. So the code that you'll be writing will be printing out this particular set of characters, which sort of gives you an understanding of how the game is working. You'll see that the command that we use for this is the command number 4. And what it does is it switches from what we call debug mode, which is this printing that we've already seen, which just prints out what the contents of the 2D array that is the minefield is. It switches from that to gameplay mode. And this here is gameplay mode. You'll need to read through more specifics around exactly how those commands work and exactly what you're expected to print out, but that's what we're asking you to do for stage 3. And that's where the core part of the assignment ends. Again, I'll give people a moment if you've got more questions. If you'd like to post them in chat, please feel free to. I want to reiterate at this point that getting through the core sections of this assignment is an achievement, and it's something which I think, if you haven't programmed before, that will be an amazing thing to do, and I think it will definitely demonstrate that you've got the required competencies to at least pass, and definitely, probably get up to a credit in COMP1511. So it's important to note, not everyone will want to do the extension parts, not everyone will have time to do the extension parts, and that's totally okay. But if you are interested in the extension parts, I'm going to talk through very briefly how they work. There's a checklist of things that we want you to do before you start the extension. Basically, this extension part is only worth 20 of your marks, so it's almost certain that you could more profitably do things like check your style, or go and work on other parts of your code. So it's important to check those things first. Oh, there's a question in chat about, does stage 3 get you to a distinction? If you complete all of stage 3, the maximum possible mark you can get in the assignment is 80%, which means if you want to end up with a distinction in the course, this would certainly put you on track for that. If you wanted to get up to a higher distinction though, you would likely need to get into the extension section to be able to work on that. Hopefully that answers your question, Lord Pistachio. Okay, so talking through the extension. First of all, we recommend that you do all of these things. Have 5 functions that you've written yourself. So you'll break up your code a little bit and make it a little bit more modular and a little bit more readable. None of your functions should be longer than 100 lines. Again, if you've got a really, really long function, that's probably something that you could fix, and we reckon you'll probably get more out of fixing that function than you will out of doing the extension work. Your code should pass 1511 style. If it doesn't pass 1511 style, discuss it with the tutor. Please try and fix the style of your code. Make sure that you've checked all of your normal labs, so we don't want people working on the extension when they haven't gotten their regular lab work done. And finally, we strongly recommend that, if you've got Math 1B on right now and you've got to get the assignment ready or something like that, then you need to make sure that we would recommend that you make sure that your other uni work is prioritized. For those of you who don't know the term, I would recommend looking up the term nerd sniping. That is somewhat what this extension is about. It's fun, it's interesting, and you'll learn a lot from it, but it's also possibly going to distract you from other work which might be more beneficial to you. There's also a question saying, stages 1 to 3 are kind of like a normal lab, and stages 4 to 5 are kind of like a challenge. It's a similar idea. The only thing I'd say is that unlike in the challenge exercises for a lab, you do need to do the extension work for full marks, at least full marks in this assignment. So there's one small difference there, but apart from that, in terms of the difficulty level, in terms of how we set this up, it's relatively simple, relatively similar. Excuse me. So, what are we trying to do with the extension work? The extension work is going to ask you to write some code, but that's not all we're going to ask you to do. We also want you to write a specification for your work. What do we mean by that? We want you to give us a description of what you've actually done. This is something that in industry you would absolutely have to do. You would have to explain to the person who's looking at your code, why have you done this, what decisions have you made, what have you changed. So it's something we're getting you to practice by writing a detailed specification. We also get you to test your own work. Again, when you're in a company, one of the things you have to do is you have to write tests, because those companies don't have 1511 auto tests all set up for you. You've got to make sure your code works for yourself. So let's say that you've decided, yep, I want to do the extension work, I'm keen, I'm excited, I would like to do this, and I've done all my other work. Here's what you do. Go back to VLab so I can follow these instructions. First of all, you need to copy this extra file. This extra file is where you can write the specification for your work, and also where you can write tests for your own work. Let's jump into VLab. So here's one thing I'm going to do. I'm going to paste this command in, and it gives me a new file The new file is called Minesweeper docs.txt. I'll take a look at that file in a moment, but the first thing I'm going to do as well is I'm also going to copy my minesweeper.c file to be called minesweeper.ext.c. It is important to note that you submit your regular core assignment and your extension assignment separately. We do that for a few reasons, but the main one is to make sure that you don't accidentally overwrite all of your Minesweeper code with extension code and then like accidentally break something, which means you can't submit either. So before you get started on the extension work, make sure that you've submitted the regular work and make sure that you've backed it up or saved it somewhere, just to make sure that you don't accidentally overwrite it. So you've already seen the starter code for Minesweeper, and all you're going to be doing is extending that code to implement increased functionality. We'll talk about that functionality in a second. The other thing you're going to have to do, like we said, is work on a specification and some tests. You can find all the instructions for where you're going to put your summary. So this is a summary, this is your specification effectively. And also you can find where you're going to put your test cases. So these are 2 test cases which test your work, which prove, I've thought about some element of my code. I've thought about something that might go wrong. I've thought about something that I need to test, and I've tested it. So this is where you would write those pieces of text. Okay, we've got that set up. So let's now talk through the extension component. Okay, so what we're going to ask you to do is, specifically, we want you to write a description of the work that you've done, which is approximately 100 words long. You're going to write that in the minesweeper_docs.txt file. For each extension you complete, you're going to need to write 2 test cases which prove that you have thought about some edge case or some possible bug that you might have written into your code. You're also going to need to submit a .c file which contains both the code for all of the regular stages, so that code should pass 1511 autotest Minesweeper, and that also will pass the requirements for the extension activities. So those are the 3 things that you would submit for the extension work. Now there's a great question in the chat, which I'll come back to in just a moment, which is about how exactly do we submit this, and particularly like what format do we need to submit it in. One of the things that we will give you access to shortly, but that isn't quite available yet, is that there is the 1511 autotest Minesweeper extension command. It works very similarly to how 1511 autotest Minesweeper works, but it checks each of the other things that we ask you to do. So when you run that command, the command will work. I'll show you what that command will look like, even though it's not quite implemented yet. The command you'll run is 1511 autotest Minesweeper ext, Minesweeper ext.c, Minesweeper docs.txt. And so what this is going to do is it will check your documentation to make sure that you've got a description of the work that you've done. It will run some basic auto tests that we have written against your Minesweeper ext.c. We call those qualification tests, and I'll talk about that in a moment. The final thing it will do is it will look at the test cases that you have submitted, and it will run them against your own code. And what that means is we can tell, does your code actually do what you think it does? Let me jump back to the specification. I'm going to talk through in more detail now how this gets marked, because I think that should clear up any sort of confusion that might exist. The way that this gets marked is in 3 stages. Before the due date, so before Friday of week 6, you submit your extension work. When you submit it, we will test it against a few things. We will make sure that it's got those 100 words of explanation of what you've done. We will also test that you've written test cases. Those test cases, all they are inputs to your program. So it's just like you typed it into the terminal, except instead of typing it into the terminal, you type it into a text file and we will run it against your program. What we want to see happen is we want to see that your test cases create the same output from your program as they do from the sample solution. So if the sample solution prints out, let's say it prints out, I'll show an example, 1511 Minesweeper. Second, get that working. So say that it prints out this, then we want to make sure that the input 1, enter 11, produces the same output on your program as it does on the reference solution. So basically, it's pretty much going to be numbers. It'll be numbers that get typed in to your program. Let me jump back to the reference implementation. So all we're asking you to do is to provide 2 sample inputs to your program, and you'll type them in the same way that you would type them in at the terminal. What we're looking for, like I said, is that each of those test cases, when you put them into your program, they cause your program to give the same output as the sample solution. Now you can imagine that if you typed in something that you hadn't implemented properly, your solution and the sample solution would give a different output, and in that case, that test case has failed. That's how we check your submitted test cases. Finally, we also have our own test cases, which we call qualification tests, and we just check your code against those. So in summary, you're submitting 100 words about the program, you're submitting 2 sample inputs that we can check your code against the reference solution, and you're also going to have to pass two inputs that we've decided that your program needs to follow. Okay, that happens all before the due date. You submit the 100 words, you submit those 2 test inputs, and you submit your .c file. After that, we then do some magic behind the scenes to run all of your sample solutions against all of your solutions against everybody's test cases. So for instance, let's say that Andrew has submitted a solution, Jenny has submitted a solution, and I've submitted a solution. All of us have also submitted 2 test cases. My test cases will get run against Jenny and Andrew's solution. Jenny's test cases will get run against my and Andrew's solution, and Andrew's will get run against my and Jenny's solution. If we've all written perfectly correct code, all of our solutions will produce the same output as the sample solution. In that case, we all get 100%. But perhaps I've written some not so great code, and I haven't thought about some edge cases that Jenny and that Andrew have thought about. In that case, when we're marking you, your peers will have written tests that catch us out, or that catch me out, and as a result, we determine the marks based on how many tests I pass. That's all that this is really saying. We run your tests against each other's code, and we see who thought of each other's edge cases and who didn't think of those edge cases. To be clear, if you've implemented something that is perfectly correct against the reference solution, you'll get full marks. But if you've forgotten to test something against the reference solution, then some of your peers might have picked that up, and as a result, you might lose some of those marks. This is really just incentivizing you to do some testing yourself. You need to think about what edge cases might your friends pick up, and you'll need to test for them. It's worth noting that you can actually also get extra marks. You can get effectively bonus marks by writing a test that catches other people out. So you're incentivized both to write good tests because you'll get marks for catching other people out, but also to test your own code because you can lose marks if somebody else finds a bug or something in your solution. Okay. That's basically how the extension gets marked. That's the idea behind how we mark the extension. In terms of what is the extension, there are 2 different things we ask you to do. One is to implement flagging mines, and you can see the game of Minesweeper, and you'll understand hopefully how that flagging system works. There's a simple description here, and additionally in stage 5 we ask you to implement diffusing mines. So diffusing mines is basically the ability to remove some mines from the minefield by following the instructions that are given here. I'm not going to go too deeply into them, because now what we're going to ask you to do is, when the extension reference solution and the extension auto tests are released, you're going to need to determine exactly how they work. You'll need to find the edge cases, you'll need to find the specifics behind how they work, and that is how that part of the assignment works. There are some nice animations as well that hopefully give a little bit more explanation of what's going on. I'll very briefly note that we've listed some other challenges as well. If you're the sort of person for whom even the extension wasn't enough work, or you've really gotten interested, there are 4 different challenges. Basically, you can work on these challenges in your own time. They're not marked. There's a mention about submission here. There isn't actually any submission for the extension work. You don't even need to worry about that. That'll probably get removed from the assignment spec later tonight. All it is it's just you can do something cool and you can mess with it yourself. Okay, that's the walkthrough of the assignment. I would recommend that if you sort of got a little bit worried about sort of stage 4 or stage 5, don't worry too much until you've gotten through stage 1. Because once you've done stage 1, hopefully you'll have all of the terms that we're using in your head, and it'll be a little bit easier to then look at stage 2 and stage 3. There's a good question in the chat about, can we ask for help or review from tutors for the extension stuff? Really good question. One of the ways that you can answer this question is by looking at the rationale, because we explain exactly what help we can provide to students. Tutors may give general debugging and programming advice, or a very general overview of the stage, basically what I've just given you. But they won't give you specific advice on how to complete the stage, and we won't help you with specific bugs. As part of that, we also won't give you specific review of, you might not have thought of this edge case or that kind of thing. Hopefully that answers the question in chat. I'll just ask now, are there any other questions? Anything you're wondering about, maybe about one of the particular stages, maybe about how you submit, maybe about something else? Any questions at all? Okay. Anything else I need to mention? The last thing I'm going to, and there may be some questions which people are typing while I'm talking, so I can come back to them in a moment. The last thing that I'm going to mention is just some general advice for this assignment. And I'd also invite any tutors who are in the chat, if you've got any particular advice that I don't mention, feel free to jump in and provide it as well. The first thing to say is, please work through this assignment in stages. And if you're a little bit worried, don't worry about stages 2, stage 3, stage 4, stage 5. Just pretend that stage 1 is the entire assignment. That is because if you're focusing on a sort of smaller goal and you're only working towards that goal, it becomes a lot more achievable. There's a lot less to worry about. And some of the words that you might hear people saying about, reveal cross or flagging mines, you don't need to worry about them. So I recommend working through this assignment in order. The second thing I would say is I recommend testing this assignment frequently. Every time you make a change, compile it and see if it compiles. If it compiles, then run auto test against it. Run auto test stage for stage 1 or stage 2. And just make sure, have you actually gotten closer to your goal? Have you done something which makes sense? If it doesn't compile, that's obviously a good hint that you might need to go and change your code. I can promise you that sort of small incremental steps where you try and get a little thing working and then it works is a much better way to approach this assignment than trying to just write everything at once and then compile it at the end. Because that then is then a lot of compiler errors and a lot of auto test bugs. So that would be the second thing. Work through this in stages. The third thing I would say is start early. If you can, download and look at the code tonight or now. I'm not sure if you're watching this live or if you're watching it later, but whenever it is, just get started on the assignment. Have a look at it, download it or copy it into your account, and just have a read through. Try and get a little bit of it done. Even if it's just scanning in the number of mines, that's something which you should already have the knowledge to do. That should have already been covered in sort of last week's and the week before's labs. So that's something you can do right now. Go and do it. Because once you've started it, it's a lot less daunting. And you'll have understood some of the terms that we're using, you'll understand the code a bit better, and it will become a lot easier to use. The other thing I would say as well about starting early is that we have help sessions in this course. The details of help sessions were posted on the course website yesterday. They are basically a time when you can go into a lab or you can go into a Blackboard Collaborate session and you can ask tutors for help. The tutors don't intend to just fix your problem, but they'll definitely give you sort of a helping hand. They'll help you understand the problem that you're having and give you the tools you need to fix the problem yourself. That is extremely useful, but it's the sort of thing where if you go into the help session tomorrow, there'll be almost nobody there. If you go into the help session on Thursday of week 6, I can promise you that there'll be lots of people there. Lots of people. So I would recommend get a start early, not only because it means that you'll have more time, not only because it means that you'll have more time to think about it and more time to perhaps work on the later stages later, but because if you would like help for the assignment, it'll be much harder to get help later in the term. That's not to say you can't get help, of course. We'll always try and provide you help, but it's much easier to get help if you go to a help session tomorrow than it is if you go to a help session in week 6. The next piece of advice I would give is about style. It is very easy to say to yourself, I will deal with style at the end. It's the same as I will clean up my room next week, or I will clean up my room later. If you keep your code clean, if you keep your room clean, there's never a time when you actually have to clean it up. If you keep your code with good style, there's never a time when you've got to go through and fix everything up. As a result, what we recommend is just keep checking your style constantly, keep everything in good style, and you'll never have to go through and fix it. So just use 1511 style regularly. If it ever reports a problem, just go and fix that problem quickly. You'll find it much more pleasant than having to go through at the end and fix your messy, long, really indented code and turn it into something readable. The next piece of advice I would give that is sort of along that track is one particular element of style. That element of style is functions. In this assignment, for the core stages, if you don't have functions, it is theoretically possible that you could get full marks, I believe. Certainly for stage 1 and stage 2, we don't absolutely expect that you know functions. But once you get up to stage 2, there was a little hint at the end there about how it would be really, really useful to use a function. We strongly recommend, once you get up to at least stage 2, start trying to think about how could I turn this into using functions? How can I split my program up into smaller sections? Why do we recommend that? First of all, because you'll have to write less code. If you have functions that do some parts of this assignment, you can use them in multiple places, and instead of having a 500-line file, you'll have a 300-line file. Second of all, because functions make it a lot easier to debug. A lot easier. Because you can understand things like, all I want this function to do is to turn this minefield into whatever. Say you want to count the number of lines in a particular row. It's much easier to test that if it's in a separate location than if you've got to draw it out of a 100-line main function and you've got to test that particular 10 lines. So it's really, really useful to have things split up into function because it makes it easier to understand and easier to test. I was trying to think if there's any other advice I'd give. Tutors, if you've got any advice as well, I'd encourage you to contribute it. If you have anything in particular to share. Ask for help. If you get stuck, you've got your tutors, you've got the course forum, you've got help sessions, you can get help. It is much better to go and ask for some help than it is to sort of try and sit there looking at it yourself for hours and hours and hours on end. So I'd strongly recommend ask for help. You can get help. Just be careful, obviously. Please don't post the full text of your assignment on the course forum. You should keep the text of your assignment to yourself, but you can ask questions about it, certainly. And if you want to get your code looked at, you can ask a tutor, and tutors will be more than happy to do that in your labs or in help sessions. There's a question about when should you start it. My advice would be start it when you've got a spare hour. Don't worry if you can't get too far into it. Don't worry if you feel like, oh my goodness, I haven't seen this 2D array thing enough yet. But at least try and get a little bit of it done. Try and get something done, just so that you can say that you've started it. Because the starting it is actually one of the hardest parts. Just getting the sort of time and convincing yourself to get started is difficult. Okay, let me just have a look at my walkthrough and see if there's anything else I've missed. I think I've spoken about everything here. So once again, I'm just going to give people some time. I'll stick around on the call for another little bit or so. If you've got questions, please feel free to ask them. I'm more than happy to stick around for a little bit and answer anything that you're wondering about. Tutors, if you've got any particular advice to give as well, I would love that. There's a question about using Booleans. A Boolean is a true-false value. That's the name that we use for it in computer science. The thing I see most people do is just use a hash define. So you can hash define something like hash define true 1, hash define 0, false 0, and then you can use the words true and false. That's something that some people will do that. There are also other ways of doing it in C, and you can ask about those on the forum to get specific advice on it. But I believe the answer is that you can use those other ways if you'd like to. Okay. Just stick around for another minute. In fact, what I'll do, while I'm waiting for any other questions, I'll play another game of Minesweeper just to finish off on the same theme as when we started. Okay, so there's probably a mine here. Okay. I'll admit I'm not very good at Minesweeper. Ooh. There's some there. Oh, there's a question. This is a statement from Jenny. Yes, you can make a rough plan. That's actually a really, really good point, Jenny. Thank you for that. One thing it can be really useful to do is to have a think about when you're going to get some of this work done. Set aside some time, make yourself a tea, sit down in front of the fire. It's rainy in Sydney at the moment, so hopefully some good coding weather, and just allot some time to yourself to code. And also try and make yourself a little bit of a plan of how you're going to do it. In the starter code, there are those to-dos there. Those are really useful for sort of giving you hints of like, you'll probably need some code here, you'll probably need some code here. But you can try and write down what your plan is. You can try and write down any questions that you've got. And if you can do that, then you'll be able to have a list of things to work on and a list of things to ask a tutor if you're not sure. So that's a great piece of advice from Jenny. Thank you. Okay. Any other advice or any other questions that we've got? Not really. Okay. I think then we'll look into we'll wrap this up. This will be available on YouTube. It'll also be put up onto Echo 360. I'll try and put timestamps in as well so that you can jump to particular sections. So when I'm talking about, for instance, stage 3, you should be able to jump directly to that. If you've got questions, like we said, feel free to post on the course forum. You can ask your tutor during tutes and labs. Some tutors will probably walk through the assignment in a little bit of detail during these tutes, which can be somewhat helpful. Apart from that, I just want to say thank you everyone for coming. Thank you for watching if you're watching from the future. Thank you particularly Jenny for all of her work on this assignment. Great, I think we'll end the call. Oh, there's a question which I'll answer quickly. Should the test cases be limited to 2 or can we have more? This is a question presumably about the extension component. For the extension component, you can only have 2 tests and you must have 2 tests. Now, your test can be very, very simple. Your test could be as simple as 1, 1, 1, like we had there. But obviously, if you have a test like that, pretty much everybody else's code is going to pass that test. You can have much more elaborate tests that maybe test a bunch of different things at once, that maybe test different parts of the extension. So it's possible to do that if you'd like to, but you can only have 2 tests. And I should say it's 2 tests per each of the stages. So for stage 4, you'll write 2 tests, and for stage 5, you'll write 2 tests. And if you don't do stage 5, if you leave the description and the tests for that blank, you can still get marks for stage 4, if that makes sense. Other than that, thank you very much. I will stick around for another 30 seconds just to make sure that there aren't any other questions as well. In fact, I'll play one more game of Minesweeper. In fact, I'll try and win this game. Okay. Thank you. If there are any other questions, feel free to post them in chat. Oh no. You'll notice that I'm not a very good Minesweeper player, unfortunately. There's a great question. Are the online help sessions on the Moodle page? Yes, they are. So they're in the same place as where your tutorials and labs would be online. So go to Moodle, go to Blackboard Collaborate. In fact, I can probably show you on here. Moodle. Hopefully I'm logged in. I'm not logged in. I don't want to risk logging in on a live stream, but you can go to the Moodle page. You would go to Blackboard Collaborate, and then there's a help sessions session in there. Well, there should be a help session in there. There's a question about how harsh is our marking. That's a great question. For the auto marking, for the first few stages, we're not trying to catch you out. We are testing you on whether you've implemented the specification correctly. So if you've missed something in the specification, it should get caught by an auto test, but it's not guaranteed that it will. So for instance, if you've messed up, or if you've got something wrong with detecting things outside of the minefield, maybe your code works if if you're detecting something to the left of the minefield, but it might not if you're detecting to the right of the minefield. In that case, we might have written an auto test that checks to the left but not to the right, and so you could lose marks there. But we're not really trying to catch you out. For the style marking, again, we're really not trying to catch you out. You can get 1511 style. You can ask your tutors for feedback as well on your style in those early stages if you'd like to, but we're not trying to catch you out on that. For the extension work, though, the marking is as harsh as your peers' test cases. Again, you are only being marked on whether you produce the same output as the reference solution, but it's more have your friends thought of some devious edge case that maybe you haven't coded up, or maybe that you've coded up but they haven't. I might do one quick note as well. If you are feeling super stressed about this assignment, if you're not feeling like you'll be able to get it done, if you're worried, if there are life circumstances affecting you, I understand particularly in Sydney at the moment, given the COVID situation, if there are circumstances related to that are affecting you, come and talk to us for help. You can reach out to your tutor, and you can reach out to the course account cs1511@cse.unsw.edu.au. We would much prefer that you reach out to ask for an extension, ask for help. We'll do everything we can. That's much better than any of the alternatives of things like you trying to reach out to friends and then getting involved in investigations about academic integrity. So if you have issues that you are facing, please let us know. Please get in touch with us, and we'll do our best to try and help you there. Okay. I might end the stream on that note. If there are any other questions, please ask them on the forums, ask them in the comments. I will stick around in the stream comments for another minute or two just in case there's any last questions that are involved. Thank you very much for coming, everyone. I hope you have a good morning, afternoon, evening, night, whenever you're watching this, and I'm sure I'll see you all soon. Bye.